asymptotes. So now we're going to put that all together and graph a rational expression by hand. So there's 6 steps, and we're going to follow those 6 steps in our 2 examples. So in this first one, we start with factoring the numerator and denominator and find the domain. So x squared minus 1 is a difference of 2 squares. So x squared is x times x, and 1 is 1 times 1. So x minus 1 and x plus 1 will bring you back to x squared minus 1. And then the bottom is just x. We find the domain by setting the bottom equal to 0. So x cannot equal 0. And you can write that as x such that x cannot equal 0. 2. Write in the lowest terms. So this is like factoring and simplifying the expression if it can be. So if we look at the function of x minus 1 times x plus 1 over x, this cannot be simplified further. So r is in lowest term. All right, 3. We're going to find the x-intercepts and the y-intercepts. So when we think of the y-intercept, you plug in 0 for x and solve. But in step 1, we said x can't equal 0. So we have no y-intercept. And then for the x-intercept, you set the function equal to 0 and then solve for x. So we would say 0 equals x minus 1 times x plus 1 over x. We can start by multiplying each side by x. Get 0 equals x minus 1 times x plus 1. Set both equal to 0. X plus 1 equals 0. And we get x equals 1 and negative 1. So those are our x-intercepts. Step 4, locate the vertical asymptote. If we remember, the vertical asymptote is your domain. So we have a vertical asymptote at x equals 0. Number 5, locate the oblique or the horizontal asymptote. And if we look at this, our degree in the numerator is 2 and the degree in the denominator is 1. So if we look back on those asymptotes rules, the numerator is exactly 1 more than the denominator. So this is an oblique asymptote, and you divide the coefficient, you divide the numerator by the denominator. So we're going to take x squared minus 1 and divide it by x. And so we get x squared and then minus 1. That's just our remainder. So our oblique asymptote is at y equals x. Now we're going to take all this information we just found and graph it. So the first thing I'm going to do is put in those asymptotes at x equals 0 and y equals x. I'm going to do my graph in pink. So I'm going to place markers. And I have an x-intercept of 1 and negative 1. Now I'm going to use my asymptotes as a guide to graph my function. So I'm going to go from my intercept and go all the way up to that asymptote, but don't actually touch it on both ends. And then same thing for the other one. Go to the asymptote, but don't touch it. Just get really close. And so that is our final graph, and that was step 6. All right, let's try it for this next one. So first, we are going to factor the top and bottom. So we have 2x squared minus 5x plus 2, which can be factored as 2x minus 1 times x minus 2. And then again, we have an x squared minus 4, which is the difference of 2 squareds. X times x is x squared, and 2 times 2 is 4, and there's a minus. So that's a difference of 2 squares. And that can be factored as x minus 2 and x plus 2. And then find our domain. So set the bottom equal to 0. So x minus 2 cannot equal 0. and x plus 2 cannot equal 0. So x cannot equal negative 2, x cannot equal 2. So we can write our domain. X cannot equal negative 2 or 2. Second, we're going to write this in lowest terms or simplify what we have. In number 1, we can notice that we have an x minus 2 on the top and bottom. So this can be simplified to 1, or you can call this like cancel. So we would have a 2x minus 1 over an x plus 2. This is x equals 2, and x cannot equal 2. And then we would then have a whole at x equals 2. Whoops, and this meant to be x cannot equal negative 2. And the whole happens because in the first step, we said that x couldn't equal negative 2 and 2, but then once we put it in lowest terms, we had an x plus 2. So this gave us the negative 2. But that 2 then is gone when putting it in simplest terms. So that's why there's a hole there. Okay. So step 3, we are going to locate the intercepts of the graph. So for the x-intercept, that's when y equals 0. Or you can just set up your numerator equal to 0. And you do it from your simplest terms. So we have 2x minus 1 equals 0. And then 2x equals 1. X equals 1/2. Now looking at the y-intercept, you plug in 0 for x and then solve. And again, you do this in the lowest terms. So plug in 0, and then you get 0 minus 1 over 2, which equals negative 1/2. So y equals negative 1/2. Step 4, let's see if there's any vertical asymptotes. This happens at your lowest terms as well from step 2. So we have a vertical asymptote at x equals negative 2. Number 5, we are finding if there's an oblique or horizontal asymptote. We look at the function in the beginning, and the degree in the numerator is 2. The degree in the denominator is also 2. So if we look back on our rules, that's going to be a horizontal asymptote, and you find it by dividing the coefficients. So we know this is going to be a horizontal asymptote. We do 2 divided by 1, which equals 2. So at y equals 2, we have a horizontal asymptote. All right, step 6, put it all together. So I'm going to put my graph down. 1, 2, 3, 1, 2, 3. Okay, so the first thing is my asymptotes. So at y equals 2, and then at x equals negative 2. And then I'm going to go ahead and plot that x-intercept of 1/2 and the y-intercept of negative 1/2. So if I look at this portion, it's going to go ahead and look at this. But don't forget that hole at 2. So when I go to 2, I'm going to go ahead and place a hole. And I'm going to erase the line going through. So right there at 2, I have a hole where the graph goes through. Since this graph is symmetrical, you can go ahead and graph the same thing on the opposite side. So go and graph your piece. And then that's it. If you have any questions, please